FastMCP2's task protocol implements a non-blocking execution model through the call-tool method, enabling asynchronous operation handling via a task object that abstracts both immediate and background execution paths. This dual-mode design allows client code to remain agnostic to server-side task support while maintaining consistent result retrieval through the await task result pattern. We're about to examine how this protocol gracefully handles server capability variations, where the returned immediately attribute signals synchronous execution while the same result retrieval interface remains functional. The code demonstrates this unified approach by first checking execution mode before proceeding to result await, showing how the abstraction maintains consistent behavior regardless of server implementation.
Task equals await client. Call tool my tool, args task equals true. If task returned immediately. Print server executed immediately, no background support. Else print running in background. Hash either way, this works. Result equals await task result.
This code demonstrates FastMCP2's graceful degradation pattern for background task execution. The client initiates a tool call with task equals true, which returns a task object regardless of server capabilities. The returned immediately flag indicates whether the server executed synchronously or asynchronously, allowing the client to adapt its behavior while maintaining a consistent interface. The pattern ensures backward compatibility by handling both immediate and background execution paths uniformly. When the server supports background tasks, the operation runs asynchronously, and the client can continue other work while awaiting results. For servers without background support, the operation executes immediately, with the result available inline. This approach lets developers write task-aware code without worrying about server capabilities, as the await task result call works identically in both scenarios. The trade-off here is between flexibility and complexity. While the pattern provides a unified interface, developers must still handle the two execution modes differently if they need to optimize for immediate results or provide background-specific UI feedback. The design prioritizes robustness over simplicity, ensuring the code works across different server implementations while giving developers the information needed to tailor the user experience. Let's break it down.
Task equals await client. Call tool my tool, args task equals true.
Asynchronously calls the myTool tool through the client interface, passing the provided arguments and explicitly marking this as a task operation. The await keyword indicates this is an asynchronous operation that will pause execution until the tool call completes. The task equals true parameter suggests this operation should be treated as a background task rather than a synchronous blocking call.
If task returned immediately. Print server executed immediately, no background support.
Checks if the task's returned immediately attribute is true, and if so, prints a message indicating the server executed the task immediately without background processing support. This conditional statement provides feedback about the execution mode based on the task object state.
Print running in background.
Outputs the string running in background to the console.
Result equals await task result.
Awaits the completion of the asynchronous task and retrieves its result value, assigning it to the variable result. This line pauses execution until the task finishes, then stores whatever value the task produced. FastMCP2's task protocol elegantly bridges synchronous and asynchronous execution through a unified task abstraction. The call tool method with task equals true initiates the operation, returning a task object that encapsulates both execution modes. The returned immediately flag serves as the pivot point, letting client code detect server capabilities while maintaining identical result retrieval via await task result. This design choice prioritizes robustness over simplicity, ensuring consistent behavior across server implementations. The trade-off surfaces in the conditional handling of execution modes. Developers must still account for immediate versus background execution if optimizing UX, but the core result retrieval pattern remains unchanged. By abstracting server differences behind a single interface, the protocol achieves graceful degradation without sacrificing functionality.
The task that runs in the background still waits for its result, like a server holding its breath.